project on the order of the Human Genome Project or the War on Cancer. The President not only mentioned it in his State of the Union speech, but is preparing, so we understand from reports, to propose spending $3 billion over the next 10 years.
And it's not as simple as mapping the brain geographically in the brain. There's sort of, you know, those of us who have teenagers, that old frontal cortex doesn't quite develop, so that there's a lot of impulse control issues until somebody reaches about, oh, I don't know, 35, 40.
The biggest challenge is actually figuring out how these connections are made, because they are extremely tiny, and what triggers them and how. Multiple connections within individual cells then react against each other.
How those interactions create the wonder of, at a beautiful piece of art, for example. You can capture an image on an fMRI, but you can't necessarily explain it. So my guess is that there will still be a lot of mystery left in the brain and a lot of sort of art in the science.
Scientists and engineers recognize that nature has about as perfect an example of engineering as you can find. And if scientists and engineers can understand how nature works, then they can perfect better machines themselves. The continent of Africa is littered with broken and rusty pieces of machinery donated by well-meaning aid agencies that have fallen into disuse simply because nobody figured out beforehand just what it was that the local recipients needed and how they were going to use it and how they were going to go about getting repairs.
The last time I looked, very, very few problems worth solving were discipline specific. In Africa, there was a wonderful project to design an inexpensive, smokeless, super efficient cook stove for an African village that lacked firewood, and most of the cooking was indoors. And they came up with all this great stuff. They donated it to the village, and things, well, they didn't sit on shelves because they didn't necessarily have stuff, but they were not used. So when an anthropologist went in with the engineers, they found that the stoves were too small for the typical family and the typical family meal, and too narrow for the clay pots that were typically used to prepare the meals. Social scientists, philosophers, anthropologists use different terms and seek a different set of data. When you want to collaborate, what we're finding is that these pockets of collaboratories, if you will, are springing up in centers or departments that combine science and the social sciences.
Social scientists can raise questions that then engineers can try to address with technology.
An engineer collaborating with somebody who knows, say, the regulatory process, a political scientist, will be able to develop a product that in fact doesn't raise as many health concerns.
The more that engineers are involved in medical research and bioengineering, the more they come into contact with the whole idea of animal testing.
If you are creating one of those nanoblock sunblocks, you can't bring it to market without proving its safety and its, well, obviously its efficacy, but also whether it causes a fever in a living creature. The engineers find themselves in that interesting ethical space as well as that interesting research space.
Technological advances enable much greater sophistication in tests without using animals at all.
You put a cell on a chip and examine what the effects are and extrapolate from there.
Sheer volumes of data can fill gaps, and you can pretty well predict how, for instance, a particular medication might behave inside a human body.